1.8, B is in Bravo, and we are in example number 3, bottom of page 89. Now this is one of those story problems where they give you a lot of information that you don't even need, and you have to pick and choose what you're going to do. So population change information states that there is one birth every 8 seconds, one death every 12 seconds, and one international migrant every 29 seconds, whatever that is. Use this information to find the average number of births in 1 week. So use this information. Do births have anything to do with deaths? No. Do births have anything to do with international migrants? No. So we're going to throw that stuff out. We're just going to look at one birth every 8 seconds. And what does it want us to do with that? Use this information to find the average number of births in 1 week. So we are going from births per second to births per week. So the only thing we're looking for is to change seconds to weeks. Births, I mean, you can't change that to anything. Birth is birth. So that's all we're going to be doing is changing from seconds to weeks. So here is my initial units that I've got. One birth per 8 seconds. We're changing seconds to weeks. So the way I do this, times line. Seconds is on the bottom, so I know seconds is going to go on the top here. But going from seconds to weeks, do I know how many seconds there are in a week? If I did, then I'd be done. I would put however many seconds there in 1 week. But I don't know how many that is, so I have to slowly get to weeks in order to solve this. So let's get moving on this. Do I know anything about seconds that goes to a longer period of time? I mean, obviously we've got weeks, but I know there are 60 seconds in 1 minute. So I'm going to go there because I know that, and I'm going to slowly work my way to weeks. So I've got seconds on top, seconds on the bottom. I'm going to keep going. Times a line. And I have minutes on bottom, so it goes on top here. Do I know minutes to weeks? No, I don't. But do I know minutes to what? Hours. Okay. Then I can cross out minutes here and minutes there. So now I'm to the point where I could find out how many births per hour, but I need to keep going if I'm going to try to find weeks. What do I know? Okay, hours goes on top. What do I know about hours and weeks? I don't, but I do know that there's 24 hours in 1 day. And then I cross that out with that. Then I go here to here. So now at this point, if I stopped, I'd find out how many births per day. But that, again, is not what I'm looking for. So I put day up there. Do I know anything about days and weeks? Yes. And then I cross out day, and all I have left is weeks, and that's what I'm looking for. Births per week. That being the case, I know I'm at a being done place. So now I multiply everything on top. Over everything on bottom. Well, 1, 1, 1, 1. So I'm going to multiply all of that, 60, 60, 24, and 7, and then divide that by 8. And when I do that, I get 75,600 births per week. And I'm done. So example 4 talks about volcanic rock on some place in Hawaii, which I can't pronounce. The volcanic rock on the island of Kauai, maybe, is approximately 5 million years old. Hawaii is 519 kilometers from some other island, the volcano on the island of Hawaii. This means the Pacific Plate is moving 519 kilometers every 5 million years. What is the rate of movement in centimeters per year? Okay, so what are we doing? We're looking for movement. So we start with 519 kilometers per year. 519 kilometers. Oops, I'm sorry, not per year. I was going to say, that's an awful long way. Per 5 million years. We're going from kilometers per 5 million years to centimeters per year. So we've got a couple different things that we're looking at changing. We're looking at changing kilometers to centimeters and 5 million years to 1 million year. So here's what we're going to do here. So this one's done a little bit different, and the reason for that is all the other ones we've had a number up here, and we had per year, per mile, or something down here, where this number down here was 1. But because we have two numbers here, and this is 5 million years, if I take 519 divided by 5 million, that'll give me how many kilometers that plate moves per year. And that's what I want. So first of all, I've got to change this to how many kilometers per year, not per 5 million years. So if you take 518 and divide it by 5 million, you get 0.0001038 kilometers per 1 year. Not very much. Now let's change kilometers to centimeters, and we'll be done since we're already at 1 year. So, a time sign and a line. Do we know anything about kilometers and centimeters? No, but I do know, and again I put that down there, I do know that there are 1,000 meters in 1 kilometer, so those cancel. I make a time sign and a line. Do I know anything about meters and centimeters? Yes, I know that there are, in 1 meter, there are 100 centimeters, so I can cancel those. And centimeters is what I'm looking for. Years is what I'm looking for. And notice those are the only 2 units that are not crossed out. So that's how I know that I'm done, is because it is what I was looking for here. So what I'm going to do is I'm going to multiply this times this times this. And when I do that, I get 10.38 centimeters per 1 year. So 10 centimeters is about 3-4 inches, something like that. Let's convert that to inches, because it makes it a little bit easier. 4.08 inches. So about the distance from here to here is about how far that volcano moves, or that plate moves, per year. So example 5 talks about high-speed avalanches, and they're telling us a couple different things. They're saying that at its slowest speed, it goes 10 meters per second. At its fastest speed, it goes 100 meters per second. So what it's asking for is, could you outrun one of these flows on foot, on a bicycle, or in a car? So first of all, we need to, being Americans, figure out how fast this is in something that makes sense to us. 10 meters per second doesn't help me. I want miles per hour. So if I could figure out how fast this is in miles per hour, and this, how fast in miles per hour, that would make sense to me because I can look at the speed of this in miles per hour and the speed of this in miles per hour and see, okay, could I outrun it? How would this work? So we're going to convert both of them. So let's take the 10 meters per 1 second times line. And we are going to have to convert both miles and seconds, or I'm sorry, meters and seconds to miles per hour. So let's do meters first. So meters goes down here. So meters are down there. Do I know anything about meters and miles? I do not. So I'm going to convert to kilometers because I do know something about a kilometer. So that and that cancel. But that's not what we want. We don't want kilometers per second, so we keep going. Put kilometers down here. And I do know that there are 1.61 kilometers in 1 mile. So therefore, I'm done with my distance because that's what I'm looking for is miles. All right, so now what we're going to do is we're going to go from seconds to hours. So I'm going to make another time sign, line, seconds goes on top, and I don't know anything about seconds and hours, but I know there are 60 seconds in 1 minute. But that's not what I want, so I keep going. Times, I know there are, I'm going to put minutes up here, and I know hours now, 60 and 1. So I'm going to cancel minutes and minutes there. So hours. So the two things that I do not have canceled are miles and hours, which is what I want. So now I'm going to multiply 10 times 60 times 60 and divide that by whatever 1,000 times 1.61 is. And I get 22.4 miles per hour. When I do it with this one, which I'm going to do the exact same thing, the only difference is instead of a 10 here, I'm going to have 100. So I don't have to go through and do all of this work here because I'm changing it to the same miles per hour. So nothing changes here, just that this is 100 instead of 10. So when I change that to 100, or I just basically add a 0 to my answer, or move my decimal point over 1, I get that. So my two speeds are 10 meters per second, which is 22.4 miles per hour, 100 meters per second, which is 224 miles per hour. So I could get in my bicycle, get in my car, and outrun at this speed, but ain't nothing going to outrun this on foot, really. So unless you had a Maserati or something that could do that. So anyway, let's move on to example number 6. And I think that we're just going to try to get done in one video. So for example 6, we can solve this two different ways. We've got a bottle of vitamin C that has 50 tablets in it. Okay, and each tablet has 250 milligrams of vitamin C. So it's wanting to know the total number of grams. So we're trying to change milligrams to grams. But first of all, we've got a couple different directions. We can multiply 50 times 250 and find out how many milligrams of vitamin C are in the entire bottle and then change milligrams to grams. Or we can find how many milligrams are in one tablet, change that to grams, and then multiply it by 50 tablets. Either way works. It doesn't really matter. I would rather find out how many milligrams are in the whole bottle. So there's 12,500 milligrams in that whole stinking bottle. And now I'm just changing milligrams to grams. So the conversion is 1 gram to 1,000 milligrams. These cancel. I multiply 12,000 times 1, which is divided by 1,000. So then that tells me there are 12.5 grams in the entire bottle. And that's all you have to do for that. Okay, number 7, we are converting from metric to the English system. So we've got an engine that has a 2-liter displacement. So when you look at a car with a 5.0 or a 7.3 or something, those are liters. In the olden days, when I was a kid, you used cubic inches to decide what size engine you had. You had a 350 or a 283 or something, and those were cubic inches. And so sometimes us old timers like to go back to how many cubic inches that is because it makes more sense. So 2 liters, I don't really get that, but if I know how many cubic inches it is, it makes more sense to me. So what we're doing is we're changing liters to inches cubed or cubic inches. So they give us in the formula or in the problem that 1 cubic inch equals 16.39 milliliters. And a milliliter is a small unit that takes 1,000 of them to make a liter. So let's write down what we've got here. We've got 2 liters and we're changing it to cubic inches using this as our conversion from metric to the English system. So let's go ahead and do what we can here. Liters, we're going to go to milliliters because that's what we have right here. And then once we get to milliliters, we can move it over to inches. So that being the case, liters cancel. We make our handy dandy time sign line. And this is where we change from milliliters, 16.39 to 1 cubic inch. So what can we cross out? Milliliters, milliliters. So all we're left with is cubic inches. So that's how I want to end. So I know I'm done. So 2,000 divided by, and when you get your calculator and divide that out, you get 122 cubic inches, which is awful itty bitty for a car, especially when a decent car had, a 283 or a 350 in it. When I was a kid, at 122 is not a whole lot of size. So anyway, let's look at 8. Example 8, we'll be done. Okay, so example 8, I decided to just put the picture of it up here and talk you through it because it is going to be so much easier if I do this. So we have this distance from here to here is 2.5 light years, where a light year is the distance light travels in a year. If we assume the light travels 186,000 miles in 1 second, we're looking for the distance between here and here. Okay, so light travels from here to here. It takes 2.5 years for light to travel. So if we're looking at how far it is from here to here, we take how fast light travels in 1 second, find out how many miles it goes in 1 year, and then multiply that by 2.5 to find out how far it is, because it takes 2.5 years for light to get across here. How many miles is that? So we're going to first of all go from our miles per second. We're going to have to figure out how many miles this goes in a year, and then multiply that by 2.5 years. So we did our 186,000 miles per second, and we're going to change this to years. So 60 seconds over 1 minute, crossed out the seconds here, and then we went from minutes to hours, hours to days, and days to a year. And notice our year is not crossed out, so we know that's our stopping point. So we multiply all of these numbers and we get this. That's how many miles it goes in a year. So then we take this and multiply it by 2.5, and that will tell us how far it is from here to here. And in this case, it is 1.47 times 10 to the 13, or basically 147. Whoops, that isn't a 7. That many miles, which, let's see if I can figure that out. 1,000, million, billion, trillion, 14,700,000,000,000,000 miles across, which we have absolutely no concept of. So anyway, that is 1.8, and we're done.